It is a Friday evening in the spring of 1966, and a cotton farmer from Rogers, Arkansas, is finishing his weekly shopping at the local Walmart. He has a bag of fertilizer in his trolley, a tin of coffee, a new pair of work gloves. He turns into the sporting goods section to pick up a box of shotgun shells, and stops so abruptly that the tin of coffee falls forward and rolls off the front of the trolley, bouncing twice on the linoleum floor. Behind the counter, lying flat on the green baize display surface with a white price card propped against it, is the ugliest weapon he has ever seen outside of a combat zone. And he has seen some ugly weapons. He served in Germany in 1945. He has seen the Sten gun, which looks like a plumber's nightmare. He has seen the Volkssturmgewehr, which looks like something a desperate man assembled in a basement from whatever parts were available, because that is precisely what it was. But this weapon, this stamped steel tube with a folding wire stock and a simple pistol grip, and a 30-round magazine hanging below a receiver that looks like it was pressed out of a tin can, this weapon has its own category of ugly. The price card reads $9.95. He picks it up. He knows what it is immediately. He has seen this weapon before, in the hands of American tank crews moving through the shattered streets of Cologne in March 1945, in the holsters of vehicle drivers who could not carry a rifle, in the grip of the military police officers who guarded the prisoner of war enclosures outside Aachen. He knows that its ugliness is entirely deliberate. He knows that every ugly feature of it was ugly for a specific reason. He buys it without hesitation. What this cotton farmer is holding at the Walmart counter in Rogers, Arkansas, is the M3 submachine gun, universally known by the nickname that its appearance made inevitable, the grease gun, the weapon that the United States Army designed specifically to be ugly, specifically to be cheap, and specifically to win a war. 5 million were built. They ended up at Walmart for $9.95. This is why. To understand why 5 million grease guns ended up in Walmart stores, one must understand the problem that produced them. A problem that combined military necessity with industrial economics in a way that made the Thompson submachine gun, however excellent, completely inadequate for the demands of modern industrial warfare. By the autumn of 1942, the United States Army's Ordnance Department had reached an uncomfortable conclusion about the Thompson submachine gun. The weapon was superb. It was reliable, powerful, and effective in precisely the close-quarters combat role for which it had been designed. American soldiers who carried it in Guadalcanal and North Africa reported consistent satisfaction with its performance. But it cost $45 to manufacture in its simplified M1A1 form, and the Army needed submachine guns not in the thousands or even the hundreds of thousands, but in the millions. The arithmetic was unforgiving. At $45 per weapon, equipping 1 million soldiers with submachine guns cost $45 million. The Ordnance Department's planners, looking at the industrial scale of the conflict that American forces were entering, understood that 1 million was not the relevant number. The relevant number was considerably larger, and the gap between what the Thompson cost and what the Army could afford to pay was widening with every production estimate. The problem was not unique to America. Britain had faced the identical challenge in 1940 and solved it with the Sten gun, a weapon produced at approximately 10 shillings per copy by stamping sheet metal in workshops that required no specialised equipment. The Sten solution was radical in its simplicity. Eliminate every manufacturing operation that was not strictly necessary for the weapon to function. Use the cheapest materials that would survive combat, and accept an appearance that no peacetime manufacturer would have countenanced. The result was a weapon that could be produced anywhere, by anyone, from materials available everywhere. The existing alternatives to the Thompson were each inadequate in specific ways. The Thompson itself, despite its wartime simplifications, still required precision-machined components that specialised manufacturers needed weeks to produce. The M1 carbine, lighter and cheaper than the Thompson but firing a semi-automatic intermediate cartridge, could not deliver the volume of close-range automatic fire that vehicle crews and support troops needed for personal defence. Various European designs were available for study, but required conversion to American calibers and manufacturing practices that negated their cost advantages. The Ordnance Department's conclusion was that the Army needed a weapon that could be produced from stamped steel by manufacturers who had never made a firearm in their lives, in quantities measured in millions rather than thousands, at a price that reflected the economics of mass production rather than the traditions of precision gunsmithing. The specification was issued in late 1942. The weapon that resulted was designed not despite its ugliness, but because of it. Every curve eliminated, every machine surface replaced by a stamped one, every complexity reduced to its minimum functional requirement. What the Ordnance Department needed was not a beautiful weapon. It needed the cheapest possible weapon that would reliably put .45 ACP rounds into an enemy soldier at close range. Nothing more. Nothing less. The design contract was awarded to the Inland Manufacturing Division of General Motors in Dayton, Ohio, with the actual engineering work assigned to Frederick Sampson, Inland's chief engineer, working in close collaboration with George Hyde, a designer who had been developing submachine gun concepts for the Army since the late 1930s. Hyde had submitted various designs to ordnance trials over the preceding years without producing a winner, but his understanding of submachine gun mechanics was sound, and Sampson's manufacturing expertise provided precisely the industrial perspective that Hyde's designs had previously lacked. The weapon they designed together was a study in the application of manufacturing logic to firearms design. The receiver was a steel tube, literally a stamped and welded steel cylinder of approximately 3.5 centimeters internal diameter, with a simple ejection port on the right side protected by a hinged dust cover that doubled as the safety mechanism. When the dust cover was closed over the ejection port, a projection on the cover blocked the bolt from moving forward, a safety system of such elegant simplicity that it required no additional components whatsoever. The bolt itself was a simple, cylindrical steel slug with a fixed firing pin machined into its face. No separate firing pin, no complex locking mechanism, no precision machined surfaces beyond the minimum necessary for reliable function. The operating principle was straightforward blowback, the simplest possible automatic weapon mechanism. When a cartridge was fired, the rearward pressure of the expanding propellant gas pushed the bolt backward against the recoil spring, extracting and ejecting the spent case. The return spring drove the bolt forward again, stripping the next cartridge from the 30-round box magazine and chambering it. The entire mechanism had fewer moving parts than a standard door lock. The cyclic rate was approximately 450 rounds per minute, deliberately lower than the Thompson 700, because a lower cyclic rate consumed ammunition more slowly, reduced felt recoil to the point where the weapon was controllable with one hand, and made the manufacturing tolerances less demanding. The wire-folding stock, a simple U-shaped steel rod that folded alongside the receiver when not in use and extended to provide a shoulder support when needed, reduced the weapon's overall length from 75.7 centimeters with stock extended to 57.8 centimeters with stock folded, making it practical for use inside vehicles and armoured fighting positions where a full-length weapon would have been impossible. The stock folded and locked in both positions with a simple detent, one additional component, performing an essential function, requiring no precision machining. The completed M3 submachine gun weighed 3.47 kilograms unloaded, lighter than the Thompson M1A1 by over a kilogram, and accepted the standard 30-round box magazine of the Thompson, providing a degree of ammunition and magazine commonality between the two weapons in service. Its overall length with stock extended was 75.7 centimeters, shorter than the Thompson's 81.3 centimeters with its fixed stock. The total number of components in the M3 was approximately 30, compared to the Thompson's considerably larger parts count, and each component had been designed specifically to minimize the machining operations required for its manufacture. Production cost for the M3 was approximately $15 per weapon, one-third of the Thompson's already simplified $45 cost. The manufacturing was distributed across Guide Lamp Division of General Motors in Anderson, Indiana, which produced the majority of M3 submachine guns, with Buffalo Arms Corporation in Buffalo, New York, contributing additional output. The improved M3A1, which eliminated the manual cocking handle in favour of a simple hole in the bolt through which the shooter could insert a finger to retract the bolt directly, reduced the total parts count further and the production cost correspondingly. Total production of both variants reached approximately 680,000 cubic metres and M3A1 submachine guns during the Second World War, with continued production through the Korean War years and post-war manufacture for export and military assistance bringing the total across all production sources toward the figures cited in surplus accounts, though complete consolidated documentation across all manufacturers, all periods, and all export recipients remains difficult to establish precisely. In combat, the M3's performance reflected exactly what its designers had intended, not the precision excellence of the Thompson, but the brutal adequacy of a weapon that cost $15 to make and was available in quantities that the Thompson could never match. In the Rhineland campaign in the winter of 1944 and spring of 1945, American tank crews operating Sherman tanks in the close-quarters urban fighting of the German industrial cities carried M3 submachine guns as their personal defensive weapons. The weapon's folding stock made it possible to fire from a tank hatch or a vehicle cab without the full-length weapon becoming unmanageable, a practical advantage that veteran crews described as decisive in the moments when enemy infantry approached their vehicles in close terrain. The Thompson would have been equally effective at close range, but considerably more difficult to handle in the confined spaces of a tank turret. OSS operatives in occupied Europe carried both the Thompson and the M3 on clandestine missions, with the M3's simpler mechanism and lower manufacturing cost making it the practical choice for weapons that might need to be abandoned or destroyed to prevent capture. The M3A1 variant, with its direct bolt retraction system eliminating the cocking handle, was particularly valued for its resistance to fouling. The open bolt mechanism and simple construction, giving it a tolerance for adverse conditions that more complex weapons could not match. In Korea, the M3A1 served with American forces through the entire conflict, its reputation for reliability in the extreme cold of Korean winters. The simple blowback mechanism, having fewer cold-sensitive components than more complex designs, making it a valued alternative to weapons that required more careful maintenance in adverse conditions. Marine Corps tank crews in particular retained the M3A1 in service long after the Thompson had been largely withdrawn from frontline use. The weapon's practical advantages in the confined spaces of armoured fighting vehicles overcoming any aesthetic objections that its appearance might have provoked. If you are finding this interesting, a quick subscribe helps more than you know. The comparative record of the M3 against the weapons it was designed to replace, and the weapons its adversaries carried, reveals the extent to which the Ordnance Department's original analysis had been correct. The German MP40, which the M3 most directly resembled in its manufacturing philosophy, was itself a stamped steel weapon, produced by methods that prioritise manufacturing economy over aesthetic quality. The MP40 weighed 3.97 kilograms, half a kilogram heavier than the M3, and fired the 9mm Parabellum cartridge from a 32-round straight box magazine at approximately 500 rounds per minute. Its production cost was comparable to the M3's at approximately $15 in equivalent terms, reflecting the similar manufacturing philosophy that had produced both weapons. German soldiers who encountered the M3 in the field described it with a mixture of professional respect for its simplicity and personal contempt for its appearance, a reaction that the weapon's designers had anticipated and entirely disregarded. The Soviet PPS-43, produced in Leningrad during the German siege as a weapon that could be manufactured in a besieged city from available materials, represented an even more extreme application of the manufacturing logic approach that the M3 embodied. The PPS-43 was produced at approximately $6 per weapon, cheaper even than the M3, and its all-metal construction with folding stock and 35-round curved magazine made it arguably the most thoroughly rationalized submachine gun of the entire war. Production during the siege of Leningrad alone exceeded 350,000 weapons, a figure that demonstrated the validity of the manufacturing approach under the most adverse possible conditions. The British Sten remained the Commonwealth's primary submachine gun through the entire Second World War, produced in quantities exceeding 4 million across multiple variants. Its 10-shilling production cost was less than the M3's $15 equivalent, achieved through even more radical simplification of its already simple design. The Sten's 9mm caliber and 32-round magazine gave it adequate close-range effectiveness, and its suitability for clandestine manufacture made it the weapon of choice for supply to resistance networks across occupied Europe. The manufacturing simplicity that both the M3 and the Sten embodied reflected a genuine tactical and industrial insight. In a conflict of this scale, a reliable weapon that could be produced in millions was more valuable than an excellent weapon that could be produced in thousands. The Thompson M1A1, which the M3 was designed to supplement rather than replace, retained its position as the preferred weapon of units that could choose their own equipment. Rangers, Airborne, OSS, throughout the war. The Thompson's greater mechanical complexity translated into a marginal reliability advantage in extreme conditions and a considerably greater weight and cost. Among the general infantry and support troops for whom the M3 was primarily intended, the lower cost and greater availability of the grease gun outweighed the Thompson's quality advantages in every practical calculation. The post-war surplus of M3 submachine guns followed the by-now-familiar trajectory of American military surplus disposal, from frontline service through reserve storage to the commercial retail channels that would place them behind a Walmart counter at $9.95. Walmart Hunoikau Moore, whose founder Sam Walton had built his retail empire in Rogers, Arkansas, on the principle that ordinary working Americans deserved genuine value rather than retail tradition, became one of the primary retail faces of the surplus M3 trade. The $9.95 price point for a weapon that had cost $15 to manufacture in 1944 represented the arithmetic of surplus disposal, a government offering what it no longer needed through the most efficient commercial channels available. The cotton farmer from Rogers, who had stopped so abruptly that his tin of coffee bounced across the linoleum floor, understood the transaction perfectly. He had seen the M3 in the hands of tank crews moving through the ruins of Cologne. He knew what it was designed to do and what it cost to build, and why every ugly feature of it was ugly for a reason. $9.95 for a weapon that had helped win a world war seemed, in that knowledge, like something between a bargain and a historical monument available for less than a bag of fertilizer. The Gun Control Act of October 22, 1968, ended the Walmart grease gun counter as definitively as it ended every other surplus military firearms transaction in American retail. The price card came down. The surplus pipeline closed. The weapons already sold stayed exactly where they were. A registered transferable M3A1 on today's collector market commands between $4,000 and $8,000, considerably less than the Thompson or the Bar, reflecting the grease gun's reputation as the unglamorous workhorse of the American arsenal rather than its famous cousin. The $9.95 Walmart purchase has become, through the arithmetic of federal legislation and 6 decades, one of the most understated bargains in the history of American retail. Return to that Friday evening in Rogers, Arkansas. Return to the cotton farmer standing at the Walmart counter. He has seen the M3 in combat. He knows it is ugly. He knows it was designed to be ugly. He knows that every ugly feature of it was chosen because it was cheaper to manufacture than the alternative, and that the men who chose that ugliness were right, and that the war was won in part because they were right. $9.95. 5 million grease guns were built because the army needed a weapon that cost $15 and could be made by anyone from stamped steel. They were designed to be ugly. They were designed to be cheap.